Hello, friends. So now we are moving out of chapter one. Hopefully, that frustration will be kind of blown away with this chapter. This chapter, I think, is a little bit more of a review from Science 1, so you should feel maybe a little bit more comfortable. And now we're really getting into the ideas of matter and the main concepts around it. So this is the very beginning, the very brush over of matter. We will get into more details later, so don't worry if you're like, this is really easy. I promise you it gets a little more advanced as we progress. But this is Properties of Matter, Chapter 2, Section 1. And I'm a little sick, so I'm sorry if I sound awful. All right, so after this video, you should be able to describe a substance using physical and chemical properties, identify the difference between extensive and intensive properties, describe the three states of matter, and then identify physical and chemical changes to matter. So let's just get into it. So the description of matter. And so what is matter? And so remember, matter is anything that has mass and takes up space. And the study of chemistry is based on all of matter. So we're basically studying everything that it contains some type of matter. And so the best way to describe matter is by using properties. And maybe you don't use that term to describe matter, but you do describe matter in so many other ways. So some properties of matter can be determined without altering the identity of the matter. And so what I mean by that is if I were to melt something down, like if I were to melt an ice cube, we can all agree that I still have water, I just have a different form of water. And so that's one type of property of matter. It's called physical properties. And we have also what's known as chemical properties. And so a chemical property is a characteristic that alters the chemical identity of the substance. So an example would be the ability to burn. So if something were to get burned, it is no longer that main substance that we had burned it. So if we burned up like a stick, it's no longer going to be a stick after it's done being burnt. So flammability is a good chemical property. That's an example of one. Physical properties are very much easier to see, very much easier to be able to hold and touch. So a characteristic that can be observed or measured without changing the identity of the substance. So we can look at a tennis ball and we know that it's like a green, yellow color. Some people think it's green, some people think it's yellow, so we'll just go with both. If you look at somebody's hair color, you know that it's brown, and you know that color doesn't alter the state of the hair, it's just the color. And so physical and chemical properties. Physical do not change the identity of the substance. Um, I can color my tennis ball blue, I can dye it blue, but it still has that color. It still has the ability to reverse back, if you will. Chemical properties, on the other hand, completely change the identity of the substance. It's a brand new substance. So we can break physical properties down into two different categories. Extensive versus intensive properties. So these are a part of physical properties. So some properties of matter depend on the size of the sample, while some do not. An extensive property is a property that depends on the amount of matter in a sample. So a good example of an extensive property is mass. It's a direct measurement of the amount of matter that you have. A small sample of a certain type of matter will have a small mass compared to a larger sample. Another good example of an extensive property is volume. Volume of an object is a measure of the space that object takes up. So those are good examples of extensive where you need a direct measurement to tell you how much of it that you have. Intensive properties only depend on the type of matter, and not so much with how much. So for example, um, electrical conductivity, those are good conductors of electricity. It doesn't matter how much we have. We know that we can conduct electricity just based off the idea that certain substances are good at being conductors. For example, silver, gold, and copper. And then we can also talk about like glass and plastic. These are poor conductors, and we can have a large amount of plastic, but it's not going to conduct electricity. And so that's a good example of an intensive property is electrical conductivity. Can you think of any other type of intensive properties? I'll give you like 2 seconds. So other examples could be like color, temperature, density, solubility, things that it does not matter how much of it you have. Okay, and so we'll practice that when we're doing some sorting activities in class. So again, we're reviewing basically we're talking about the beginning portions of matter and what that looks like. And so I just talked about properties. And so how we can classify matter into different types of properties, chemical and physical. But it is also important to know states of matter. There are three important states of matter that I want you to know about: solid, liquid, and gas. You may have talked about plasma as well, but for the sake of this class, we are not going to focus on plasma. Really, it's very hard to visualize, very hard to even wrap our heads around. So we are just going to focus on the three states that we can see and that I can show you. I guess gases would be harder to show you, but you get my gist. So the three states of matter that I want you to know about are the solids, liquids, and gases. And the important concept that I want you to know about, and I will talk about this in class, and I will draw pictures to help you visualize these things, but I do want you to know that a solid has a definite shape and volume, meaning I can measure the tables you sit in, right? They have a definite shape, they have a definite volume, they hold that specific shape. They can't conform to anything. So if I were to try and put that table into a container, it would be very difficult unless I built the container for the table. I cannot do it the other way around. And compared to a liquid, which has a definite volume, right? If I have 16 ounces of water in my bottle, if I spill that 16 ounces of water on the floor, I still have 16 ounces of water. It's just now in a different shape. So liquid has a definite volume, but indefinite shape. It does not have a specific shape. It conforms to the shape of the container. So like I said, if it's in my bottle compared to on the floor, I still have the same amount of liquid, just now in a different shape. Gases, on the other hand, have neither definite volume nor shape. They take on the volume and shape of whatever container they are held in. So, for example, if you consider the room our container, then that gas or whatever is absorbed into the atmosphere is then taken on the shape of the room. And then the same can be said for if I were to trap some gas in a jar, it would take on the shape of the container and the volume of that container. There's no definite. It's very conformative. And the reason for that is because of the fixed arrangement of the particles that are within those different states. And we'll talk about that. And I will again show you a picture of what those look like. But really, this is all I want you to know right now, the information I have on the slide. And last but certainly not least, we have physical changes. And I didn't get into the concept of chemical changes just yet, only because I'm devoting a whole section in a couple of days to chemical changes. So don't worry right now about chemical changes. We are going to see these things. We'll talk about chemical properties more and physical properties, but I want to talk about just physical changes right now. So we talked about properties. So property is, excuse me, things like color and it's just the idea of identifying something. The property identifies. Now we have our changes, and these are the changes that the action to the property. So physical change is a change to a sample of matter in which properties of the material change, but the identity remains the same. So physical change is going to change the property. It does the action. So for example, if I have a color, the color is my property. If I have a red apple foam deal and I want to dye or dip that apple in a different color, or even if, let's say, I want to color it in a different color. So I am going to change the property. I'm going to color. And so the action here is to color. And that would be, so my verb tense is my change and compared to my my adverb. I think that's what it is. Don't quote me on that. But the change is what's actually changing the property. So I have my red apple, I color it blue with my marker, and now I have a blue apple. The best thing about physical changes, though, is that they're reversible. So I could essentially take off all the marker on my apple, and boom, it is now red again. So these are very much reversible changes. A better example than talking about my apple is like ice melting. So I have ice and it's in my freezer. I take it out of the freezer and leave it on the counter for about 2 hours. That ice is probably going to be melted into its liquid form, water. But then if I take that ice cube tray and I put it back into the freezer, it will then freeze again. These are very much reversible processes. The properties were changed, but then were reversed back. We are going to add a little bit of your notes when we talk about this. So please make sure that you have a little bit of space or you leave a blank page because I do want to add a couple of things. I may not talk about I do want to talk about chemical changes, but not in complete detail on your slides, but I will talk about them in class just to do a comparison of the two, and so you're not super confused. And that will lead into our next discussions. If you have any questions, please ask me on Edpuzzle.